Well, good day, good evening, or good morning, whatever it is. Um, this is to introduce you to Project Falcon, which is a free software flow analysis put out by Autodesk, and you can look at it or find it on, just type in Project Falcon on a search, and you'll be needing to sign up with Autodesk, register with them, and then you can download Project Falcon and use it. And it's fairly simple to use, and you can import models and quite simply and quite easily without too much dramas, and use them for wind testing or heat testing, flow analysis. But in our particular case, we're more interested in wind testing. Now what you see here is what the front screen will look like when you open up, and there's a model already placed in the screen, which is a Porsche, an older style Porsche. Now I've just pressed my left mouse button, I'm holding it down, and I'm moving the viewing plane, as you can see, just by holding my left mouse button cursor. Very similar to what you would do in Create Parametric, and you can move it to where you want to see. Now you notice there that there's a plane splitting down the center of the car. That plane can be moved and adjusted. It's actually the plane which shows the flow of wind in a two-dimensional sort of a setting over the vehicle. And you notice how that there's got colors from red down to dark blue. Up on the top left hand side here, the indications are what that means. Red, you've given two figures up here. The one on the left hand side is the velocity in meters per second, and on the right hand side you're given pressure in pascals. And so you can see the red indicates usually the higher velocity, and the higher pressure go hand in hand. Blue is zero, and in fact the pressure is negative at the zero end. So as you'd expect, there's certain areas, especially around the back here, where on this car, which is traveling at 47.374 meters per second, so that's probably pretty quick. I'd say it's probably not far off 160, 180 kilometers an hour. That car is leaving a low pressure zone behind it, as you can see in that blue area. Alright, and there's a high pressure zone right at the front, and you can see, in fact, interesting, another low pressure zone at the window. Now when we're designing cars, we want to minimize low pressure zones, because those low pressure zones will actually create a vacuum which will suck the car in the opposite direction of the flow. So as a car travels quickly, it'll generate a high pressure resistance to motion at the front, so there, which you'd expect, the wind pressure pushing against the car. And as it travels quickly, around the back over here, it'll also develop a vacuum which will tend to want to suck the car back into that vacuum place. So it also experiences a drag, it's called, as a result of a low pressure zone which is situated opposite to the direction of motion. Okay, now more about Project Falcon. At the top here you notice there's like a compass sort of a setting over there. That compass allows you to adjust the wind direction. You can adjust it by clicking on this little arrow and moving it around, so that will give you a different wind direction flow. And you'll see each time you do want to change that there may be, if you've got a slower computer like mine with an i5 processor, you might have to wait a little while. So I might pause every now and again so we don't have to watch this while it Project Falcon reconfigures itself. So I'll pause here and come back. So it seems like it's sort of a simple movement. We move the airflow slightly, but you see solving airflow is written down here. Falcon's got to do a lot of recalculating to work out the different patterns of resistance involved in moving the airflow even slightly on the car. Okay, it's completed that now. Next thing to show you is probably something which is very important for us who want to test our own models, is how to bring in models, our own model, rather than use one of Project Falcon's. Now, if I just left click briefly on the anywhere on the screen, or I should say, if I hold left click down for a few seconds or a couple of seconds, I get this menu circle, or this menu that happens. And this, from here, we can go to whatever we want to do. We can change the appearance of the model, and we can change the sorts of way it displays airflow. We can change how it shows its results. We'll look at those in a minute, but more importantly, I'm interested in, actually, if I hold my cursor down, left cursor again, I'm interested in models, and I want to bring in my own model. I can use some samples that are here. I don't know how to cache models, but let's import a model, which is what I want to do. Now this has gone to where I've been before, onto my desktop, and I have my own model that I want to bring in. So let's try this model over here. Click on it, open it up, and Project Falcon has now brought and imported this model, which came out of Creo Parametric, and it's now going to create a mesh around it, which is a sort of a breaking up of the smooth edges into finite smaller shapes that it can then calculate with. So it's almost like creating, if you put a fishnet stocking around it and you imagine all the shapes being, the smooth surfaces being divided up into scales that can be geometric shapes, plane geometry shapes that Creo can work, Falcon can work with. Alright, I'll pause a bit more so we don't have to watch this. Okay, well there it is. It's taken probably about a minute or so, and our model is now in position, but notice it's sitting on its side, and that's not how we want it to go, because the plane, you can see, is now parallel to the bottom surface of this model that I've created. So I want to split my model around, so I'm going to hold the left cursor down and bring up my menu again. There it is. Well, it's coming soon. Okay, and I'm going to look at appearance, and let's go to result display. Result display, which we won't move to just yet, it gives us a chance to look at how we can display the various different flow lines around the object. That's not what I want. Result plane will give me an ability to move the plane up and down if I want on the car. I can flip the plane to the left, the wind plane, or flip it in other directions if I choose, but it's best to have it where it is. It's not exactly what I'm after. Yep. So let's go back and we'll move into analysis and see if that's where we have. Yeah, here it is here. So this section called orientation in analysis is the area that we want. Now I can move my model relative to the plane by clicking on these arrows. If I click it down 90 degrees, it'll move it around. It's not always intuitively obvious which way. You just have to play around with it. Now I can see that that's my car's in their right orientation now, so I'm going to click back and the car will stay there in that position. If I click back again and close, okay, so the mesh has been created again, and now my car's in the right space. Alright, now I mentioned before that we can move the plane in which the wind is being displayed by grabbing this pull handle and moving it backwards and forwards. Now I won't do that because we'll go back into recalculate. What we can do, which is worthwhile is showing you, is that we can also grab these grab handles at the back where I'm indicating here, and we can move and adjust the size of the tunnel, the wind tunnel that the car's sitting in, and that's pretty important when the time comes and we want to be able to create a road surface that's just below our wheels. Now I don't have wheels fitted to this model, but you will when you do it. Okay, so we can play around with those and move the wind tunnel to make it the right size. Now notice here that you can see the pattern of drag on this car is a bit different. So we've got, high pressured zone at the front, some blue sections at the back, and around the side here low pressured zones. Alright, now next thing would be, I'm going to left click again here to bring up my menu, is to look at creating under analysis a 3D wind flow. So rather than the wind just coming in that plane that just slices through the car, I want to create a 3D plane surface, or 3D and drag, which is down here. Now I can adjust the speed of the wind by left clicking on that icon and dragging it around. Now notice how it's got some settings like car or person or rocket. Well, a car, they say average 26 or so meters per second. That works out to be around 100 kilometers an hour. Aeroplane, if I go down to here, you'll see it's around about 216 meters per second. Rockets up about 500. So we're going to just stick around car because we've got a car. So at the moment I've got it set on about 40 meters per second. So I don't know, maybe 130, 140 kilometers an hour, thereabouts. So I'll go back. We're happy with that. And I want to try 3D and drag. Now 3D and drag, when I click on this display, it's going to give me this graph. And the graph will display several different bits of information. So looking down the bottom of the axis, you have the time figure, and at the top of the axis you have several different labels, color-coded usually. So the blue would be average, and it says CD, coefficient of drag, and there's a factor there. I think it's 0.5. Notice that these other measurements are measured in newtons, so they're forces. So that would be drag force, I assume, and this one I'm guessing would be lift force. And we've got our coefficient of drag here at 0.44. Now, as you watch this over time, these lines will change, because I think what happens is Creo kicks it off, starts it up, and then as information and data rolls in, as it analyzes the results that flow over the model, then these lines will start to converge, and eventually over some time you'll end up with the three lines being very close together at a certain coefficient. And that's about all I can tell you for that at the moment. Okay, now looking at our car here, let's see if we can get some wind blowing over it in a three-dimensional sense. So if I hold my left cursor down here now and I look at analysis and I click 3D, may try that one more time, and yeah, okay. What you're looking at now is a 3D version of the wind flow. So the central plane with the wind travelling on it has disappeared, and now it's been replaced with a 3D wind flow. So that happened through looking at analysis, and it's actually choosing 2D at the moment, showing 2D. 3D should provide us with a good bunch of wind flow that we can see. Yeah, so you can see a 3D now shape with airflow flowing over the car. Also, interestingly enough, is to watch the high pressure zones. Notice the red is the higher pressure area. Quite high pressures now. The velocity is 109.520 meters per second. So if we worked out that times 60 times 60, and we divided that by 1,000 kilometers per hour, 1,000 kilometers meters per kilometer. So it's traveling at almost 400 kilometers an hour. So it'd have to be a Bugatti Veyron or something like that to produce that type of material, that type of speed. But that's what the wind flow would look like at that speed. Now I've chosen to display that with tubes. You could choose to change the way that looks. So see down here in flow line settings, if you click on flow line settings, you can change the speed at which your flow lines appear. At the moment they're going quite fast. I can slow the flow lines down if I want to by dragging that down. You can change the size of the flow lines. I'm using tubes, so the size is 150. I can make them thinner so they appear to go thinner, as you can see, or make them thicker and fatter so that they appear to be fatter, and I can see some sort of more of an indication. So you can change and play with those dimensions. You can also change how many of them there are. So do I want just a few passing by, or do I speed them up and create a whole lot of them? So you can adjust and play around with those to suit yourself, so you can get the clearest understanding of what's happening to the airflow around your model. Looks pretty good. It's quite a lot of fun to get that. Sometimes I've had difficulty going from 2D to 3D, and it needs a bit of patience and a bit of playing around, and I suspect that's because my processor here is on my computer is not all that quick for this level of taxing service it has to do. Okay, probably one other thing to go to look at would be in analysis. We've looked at orientation, which flips all around in different directions. You can also look at resolution, and you can change the resolution. I've got it at 109%. You can drop that resolution down and your processor may perform a bit better. It does sacrifice appearance a little bit. Okay, so we're going to change it back to let's try 3D and drag. It hasn't shown me much difference. Alright, let's drop it back to 2D and see what happens then. Okay, so with the 2D setting, you can see that it's now produced that movement on a single plane, single flat plane. So that's rather interesting. So that plane could be moved using the drag bar from side to side. I won't do that because it'll take a while to recalculate, but you can get a good indication of the turbulence that happens behind the model there, and that turbulence would create drag, which would slow the car down. Whereas at the front here, you notice it's a fairly smooth. So my car design would benefit me to drop the back of this car down to let the air flow over it smoothly, rather than that stiff, that sudden drop right from the top, creating all that turbulence behind the car. Alright, let's look. That's a brief introduction to Project Falcon. It has a lot of potential. Just before we depart, look at the graph down here now. It's been running for a while and it's leveled out, and you can see the average coefficient of drag is 1.27, which is quite high, and I suspect it's because of the back tail, that sudden drop down here. That's what's causing it. So I should be able to alter my design of my car, bring it in again, and see if I can drop this coefficient of drag and watch the air flow smoothly over the car for efficiency's sake. Okay, see you later on.